Hello and welcome to my lesson on statistics 2. In this series I wish to do presentation on statistics 2, including the measures of central tendency, measures of dispersion, and I'll also take you through how to draw the Ogib curve and use it to determine quartiles, percentiles, and deciles. But for a start today, I want us to, that is given there, for this table here, I'm going to include the midpoint. And the midpoint is this axis here. The axes are just gotten by averaging the values that are given in the classes. For example, we have 0 to 19 in the first class. You just get 0 plus 19 divided by 2, you get 9.5. If you get 20 plus 39 divided by 2, you get 29.5. And on all through, so that for every class we have its corresponding f of x. The next step is we look for a value of f of x. F of x means f times x. That means the frequencies times their corresponding x values that have just been found in the previous step. In which case we're going to have this column developed here, and the 85.5 is actually 9 times 9.5. The 568.1 is actually 19 times 29.9, and all these values are actually developed by multiplying the f's times corresponding x values. For example, in the class where we had the 160 to 179, we only had f is 1 unit, and because the average is 169.5, so 169.5 times 1 is 169.5, and on and on. So in that step there, we develop the f of x column, and now we go to looking for the sum of f's and sum of f of x. Now, sum of f is just addition of these values here. 9 plus 19 plus 22 plus 18 all through up to plus 1. And that one gives us 100. So sum of f of x is 100. The same case of also sum of f of x, we just add these values in the column of f of x. We add them all through. The values will add up to 6,470. So that's the next step there. Then we now go to looking for mean. In the introduction, I showed you that mean is gotten by sum of f of x divided by n. In our case, sum of f of x is 6470 and n is 100. Therefore, mean will be 6470 divided by 100, in which case our answer will be 64.7. I hope that's clear. Basically, when you're given a question, you will be given the classes and the frequencies. So to operate mean, when you're not using assumed mean, you just need to develop two other columns. That's the x columns. That's x means midpoints, which is like an average of the classes, and f of x, which is f times the midpoint. And to operate the question, you need to just find the sum of f, that is add the frequencies that are given there, and again you also add the f of x, so you add those ones together, and dividing this figure you get here by the figure you get here, that gives you the mean. Now that same value will be arrived at if you are using assumed mean, and let's attempt the same question using assumed mean. So our assumed mean in the question will be, we choose it to be 85. It will be a value from ranging from either the smallest to the biggest value. Any value between there can still be used as assumed mean. So in our case, we use 85. And so the first thing we do is we determine the d values for each class. That is deviation from the assumed mean. And so for the data we were given, we had the classes, we had the frequencies. Earlier on, we just looked at the x's, how we get the midpoints. Now we look for d values. The d will be the x minus the assumed mean. For example, this negative 75.5 here is gotten by having 9.5 minus 85. It gives us that. Again, negative 55.5 will be 29.5 minus 85, which gives us that figure there. Again, that negative 35.5 will be 49.5 minus 85. All through these values here for the d's, it is just deviation from the assumed mean, or how does the midpoint deviate from the given mean, and that's basically how you develop that column there. The next step is we look for f of d. That means we now multiply the frequencies with the corresponding deviation from the assumed mean. That is the d's. That gives us another column, and this is the column here. So we have negative 679.5, which is 9 times negative 75.5, which gives us that figure there. Again, we'll have 19 times negative 55.5 gives us 1054.5 all through. So the f's times the corresponding d values gives us f of d. I hope that's clear. Again, we go to determining the sum of the f of d. We just find the sum of these ones. That means you just go to your calculator and add these ones together. Please take care of the negatives. A simple way of doing that question is just add the positives together. Again, separately add the negatives together and just get add the positives minus the negatives. Or however way, you can just type the negative, the next number there, negative 781, negative 279, plus, and all that. They'll just give you the figure there. So adding those ones there will give you negative 2030, which is sum of f of d. In other words, all deviations from the assumed mean for every class as added together gives us negative 2030. So now we go to how to look for the mean. Mean will be given by this formula, which was given at the introduction. It is given by a plus sum of fd all over n, in which case d will be a x minus a. Now remember that a is the assumed mean that is given. In our case, it will be 85. Sum of f of d is negative 2030, and the n will be 100. And so there it is. We have 85 plus negative 2030 divided by 100, and the answer gives us 64.7. Remember, that's the same answer we got when we were operating the same question without using the assumed mean. Again, just in case anything is not clear, you can always play back and you'll be able to follow through. Now we go to the next step. How do you look for median for the same given data? So for median, we'll first of all need to determine the cumulative frequency. Cumulative frequency is so important when you're operating median. So we'll first of all need to develop a column for that, which is the column that I have added here. Given the given data had just the classes and the frequencies, but now I've had the cumulative frequency. As the name suggests, it just means getting the values in this column here. It means that the values are gotten by adding the f's cumulatively. For example, in the first class we had a frequency of 9. So in the second class, the cumulative frequency value will be that 9 plus 19. So 9 plus 19, 28. The next figure, 50, is gotten from 28 plus 22. The same thing, 68 will be 50 plus 18. The next figure, 81, will be 68 plus 13, which is that 81. Then 92 is gotten by 81 plus 11, which is 92, and again 92 plus 5, 97, and 97 plus 2, 99, 99 plus 1 is 100. Therefore, the cumulative frequency should always total here. This last figure here should be the same as sum of f, that the figure that we had when we added all the frequencies together. Therefore, that's basically how you develop the cumulative frequency. Maybe to repeat, every figure here is gotten by adding the previous frequency. At the beginning we had a 9, so we just have 9 here at the beginning figure. But 28 is just 9 plus 19. 50 is 28 plus 22. 68 is the same as 50 plus 18. 81 is 68 plus 13, and on and on. So that's how you develop that particular column there. The next step is we look for the median class. Now, the median class is actually the class where the median falls. It's a little tricky, but I hope you follow. If we have the values in the data that is given arranged in ascending order, then in this case they are given in ascending order actually, because in the first class we have 0 to 19, 20 to 20, 39, and on and on. These ones are added in ascending order. If all values were arranged in ascending order, which class will have the median value? So the median class is the class that has a middle value if all data was arranged in some order. For example, either in ascending or descending order. But obviously we use the ascending order. So this is what we do. We look for a half of the total observation. So if we arranged the 100 values from the smallest to the biggest, the 50th value and also the 50th value will be the middle value. Well, that's not accurately true, but you see, if you have 100 value and divide that data into 2, you'll have 50 figures and 50 figures. So there is no middle value. But for the sake of this calculation and also in statistics, we normally estimate. Anyway, statistics is about estimation. So we just get the 50 value, which is the 50 is gotten by 100 divided by 2. and that's what we use in for KCC questions. Therefore, you get the 50th value, which is just the middle value of that. And maybe another thing about the cumulative frequency that I need to explain. This 9 here means in the first day we had, the first, second, third, up to the 9th day, the speed of wind was somewhere between 0 and 19. This 28 here means the 10th, 11th, 12th, up to the 28th day, the speed of the wind was between 20 and 39. The 50 here means the 29th, 30th, 31st, 32nd, up to the 50th day, the speed of wind was somewhere between 40 and 59. Therefore, if I take, say, 97, what does it mean? It means that the 93rd, 94th, 95th, up to the 97th day, the speed of wind was somewhere between 120 and 139. So that should be understood. And having explained that now, what is the 50th value meaning here? It means that since we have already, coincidentally, we have 50 on the cumulative frequency here, we have a figure 50 here, it means that the middle value, which is the 50th value, is a place where the speed of wind was somewhere between 40 and 59. Now, coincidentally, we have 50 on the cumulative frequency, but in other cases, we don't have the figure that you get for the middle value. We don't normally have it in the cumulative frequency. But just in case, if, say, these observations were, say, 120, and so the middle value is 120 over 2, which is 60, we would have a 60. Where would be 60 here? We'd look for where is the 60th value. In our case, it will be in the class of 60 to 79. Why? Because we have 68 for the cumulative frequency for that particular class. It means 51st, 52nd, 53rd, on and on up to the 60th, and on up to the 68th value are in that particular class. So it's just a coincidence that we have 50 here and we also have it here. So it doesn't always happen that way. Now, having explained that, now we go to the formula. We now know the median class is 40 to the 50. It's 40 to 59 class. So we look for the median using the formula that is given. It was also said in the beginning. Now, we need to explain these values. The LT is 39.5. And where does that come from? We have the median class, which is 40 to 59. So the lower true class limit, that's what we have here for LT, it'll be given by 40 minus 0.5. So for all of these classes, what we have given here is the class boundaries. So we kind of transform them to class limits by subtracting. For the lower boundary, we subtract 0.5, and for the upper boundary, to get the class limit, we had 0.5. So for the median class, the lower boundary, which will be 40 minus 0.5, which is 39.5. Again, n is 100. That's the total number of observations, which is also the last figure for the cumulative frequency. Again, CF is a cumulative frequency just above the median class. Now, the median class is the 40 to 59 class. And the median class just above, the cumulative frequency value just above that is 28. So 28 is a figure that we have for CF. Again, we have frequency of the median class, which is 22. FM stands for frequency of the median class. The median class has a frequency of 22, and that is given there. Now the I is 20. The I means the class width, and in this case, it looks like 19 all times, but it's actually 20. And you can get the 20 by just getting the class limits, the upper class limit minus the lower class limit. For example, if you take the second class, for example, the lower limit will be 19.5, the upper limit will be 39.5. You subtract the two, you get 20. The same case for the median class. If you have the lower class limit will be 39.5, and the upper class limit will be 59.5. So if you get 59.5 minus 39.5, it will be 20. On and on. If you take any class, the class width will be 20. Majority of questions in KCSEs, the classes have the same width. So whatever width will be the first class will also be the width for the second class, and on and on. But this is not always the case, especially for cases where we have questions to do with histogram. The class width might not be 20 all through. But for this particular question, and the majority of questions that have to do with median and mode, the classes will be the same. And so in our case, the class width is 20. Now, having gotten the values, we now need to put the values in the formula. And so putting the LT, N, CF, FM, and I in the formula, we get these figures here. There's no skill that you need to put those values there. You just need to put 39.5, 100, 28, 22, and 20, and go on to operate. And the median for our data is 59.5. And basically that's it. I know that for particular teachers, the LT, N, CF, FM, and I, they use some different figures here. So they use different symbols or variables, but the figures they use for this particular question will always be 39.5, 100, 28, 22, and 20. So the answer will always be the same. And so, having explained that, we now go to the last part, which is how do we look for frequency and model class. So we are told to determine the model frequency and model class, and for the given data there, the model class and model frequency are easy to explain. They are just a value. They don't require calculation. Now, the model class is a class which has the highest frequency. If you look at the figures here, which class has the highest frequency? It will be the class which has the highest value. For F, we have 9, 19, 22, and on and on. The biggest figure here is 22. So model class is 49 to 50. Please remember, you are asked about the class, not the frequency. So when you're told to give the model class, it means the class which has the highest frequency. In our case, it will be 40 to 59. Again, the model frequency for that particular class is 22, and that's it. Now, in other cases, we will be required to give the model value. Yes, model value. Please note that in this particular question, we don't have model value. We don't have model value because we have classes, which is a range of values. We cannot have model value for this particular case. But if it was the data which doesn't have classes, like when you have 19, 9 values, 39, 19 values, 59, 22 values, and on, that way we would have the model value. In our case, we don't have model value because the classes represent a range of values. And having said that, therefore, I'm done with the 3 parts there: how to determine mean using assumed mean, and also how to determine mean using the formula that does not have assumed mean. Again, median, model class, model frequency. Now, in the next 2 or 3 days, I'll be sharing a video about how to look for the measures of dispersion, and also again the Ogilvy curve, quartiles, percentiles, and on and on. I hope you enjoy. Please like, share, and I'll appreciate your comments there.